Hello friends, today we are going to learn how to control the speed and direction of a DC motor. For this purpose, we will use a Microbit and an L298N controller, or as it is known, an H-bridge. The interesting thing is that we will do it without a Microbit expansion card. Since we will not use it, we only need 3 pins and the GND. Before we begin, let's talk a little about the L298N controller. This controller allows handling 2 motors. Here you can see that it has 2 terminals, one for motor A and one for motor B. In addition, this terminal block here is to feed the controller. If we leave this layer on, the maximum recommended voltage is 12V. We will use a 9V battery, but if we remove the coating, the maximum voltage increases to 35V. This controller also has a built-in voltage regulator. For example, if we feed it 9V, this output here will give us 5V. We can take advantage of this output for other components requiring 5V. In the center, we have the GND, which we must share with our Microbit. It is important that both the Microbit and the controller have the same GND reference. These pins here determine the direction and speed of the motor. For example, input 1 and input 2 control the first motor, while input 3 and input 4 control the second motor. To control the speed, we must remove these layers. If we remove this layer, we enable the speed control pin of this motor. If we remove the other, we would control the speed of the other engine. But in this case, we will only use one motor, so we will only use one speed pin. We reposition the layer and use only these 3 pins. This is a general description of the controller. If you want more details about this controller, let me know in the comments. Now, let's move on to the connections. Let's start by connecting the motor. We connect it to port A of the controller and adjust well. Now, to control the speed, we connect this cable to the designated pin. In our Microbit, we will use pin 0 for this purpose. For management, we connect these 2 cables to the controller. One goes to pin 1 and the other to pin 2 of the Microbit. A fundamental thing is to share the GND between the controller and the Microbit. So we connect the 9V battery and make sure everything is turned off before starting our project. We place the negative cable in the GND terminal block and share it with the Microbit. We adjust and verify that everything is properly adjusted before continuing. We now connect to the Microbit GND. The Microbit is powered by its battery, maximum 3.3V, and make sure it is turned off. Now, we connect the positive to the controller through this input. Alright, that's all. Now let's move on to the code. We open MakeCode and start by initializing the motor direction. To do so, we will create forward, backward, and stop functions. We will also add an input parameter that will refer to the motor speed. We will use the digital write blocks to define the motor direction. Since L298N is an H-bridge, we use combinations of values. 1 0 backward, 0 1 forward, and 0 0 to stop the engine. You can add our input parameter in the stop function. Let's do it quickly. Now for speed, we will use a signal. A signal that is modulated by pulse width. Microbit already has a set default frequency for ICC signals. We will use this frequency in case of more advanced projects. Then we can change this frequency for our signal. Then to control the speed pin, we will bring our analog pin, analog write pin 0. And we add it to each of our functions. I assume this signal goes from 0 to 1023. And the AMI values range from 0 to 255. 0 indicates signal off. 255 indicates always active signal. 127 indicates active part-time, etc. To do this, we create a variable that stores the velocity. And with the math block, we make a mapping, e.g. a speed of 90 on the scale from 0 to 255. We take it from 0 to 1023. We can omit this and instead call the stop function. With 0 speed. Let's modify this here. We add a 2-second pause at startup for stability. We test by calling the function forward and then stop. We add 2-second breaks. We add speeds. Ups. Download the program and connect the Microbit. We disconnect. We turn on the battery in Microbit. And we see how the engine changes direction and stops. We turn off. Ups. We set the speed to 255. This is how it would be with maximum speed. And so we have controlled a DC motor with Microbit and an L298N. If you liked it, subscribe and like more projects like this one.